Now, this is the concept of OFDM in its simplest form. Suppose this is the OFDM signal that we want to generate, and we have n subcarriers in this signal, and here we have the transmitter side and here we have the receiver side. On the transmitter side, the data is coming in the serial form, and then the serial data is converted to parallel data, and we have 9 channels of this parallel data. Now in each of these channels, the bits would be converted to symbols, and here it is important to point out that this conversion would be done according to the modulation scheme that we are using. For example, if we consider the first channel and we are using the QPSK modulation scheme, then in that case we would be sending 2 bits per symbol, or in other words, we would be converting 2 bits to 1 symbol. If we are using 16 QAM, in that case we would be converting 4 bits per symbol, and if we are using 64 QAM, in that case we would converting 6 bits to 1 symbol. So once the bits are converted to symbols, then each of these symbols is multiplied by their respective subcarrier frequencies, and then these signals are added so that we get this OFDM signal, which is a composite signal of all these signals. And when this signal is received at the receiver side, each of these symbols is then demodulated by again multiplying by the respective carrier frequencies. So once we get the symbols, then we remap the symbols from to the bits, so that here we get the bits, and we get, or in other words, we get the n channel data that we had here, and then we convert these bits from the parallel to serial form to get the original data. Now this concept is quite simple to understand, but it is difficult to implement this concept in this way, because to do that we would require n modulators on the transmitter side and n demodulators on the receiver side, and this is not a very good idea from the implementation perspective.